Okay. Good afternoon, everyone. So this CCAMP, let's start. So welcome to CCAMP session. So this is the loadware information. So you know, all the IETF participants, we should follow the IETF rules. So I think you all know the statements of the loadware information. So if you are not familiar, please just you know, review this information again. So please state your name before speaking, and you know, speak in front of the mic. So for the meeting minutes, so I think if anyone can take some minutes, you know, through the EasyPad, it will be appreciated. And I also ask my colleague Hao Mian, they can help us. So I think also the chairs will, you know, monitor the meeting echo and to say if there are some comments from the Jambo. So this time we have only one session, but fortunately we have about 2.5 hours. So I think we should have enough time for discussion. This is the agenda. So it's a little bit busy agenda. So you can see for the last slot, it's about DLab. And so if you are interested in DLab work, please take a look at these jobs. IPR stuff. So we know usually the chairs will send out IPR polling before we move to the next step. For example, before an individual draft becomes a working group document, or a working group document goes to last call, we will, you know, send out IPR polling, and it requires all the, you know, editors and you know, authors and contributors to reply the IPR as soon as possible. So and also, you know, for the list, we always encourage people to use the list as much as possible for any topic, you know, related to the working group.
So, a short update on the status of the working group and of the documents so far. We have one draft in the editor queue, the microwave framework. It went through all the final steps, so it's ready to become an RFC soon. And another draft which is being processed by the IESG, which is the DWDM Interface Management and Control Framework. This is, I would say, on hold. We just sent a liaison to the ITUT, informing them about this work and asking for review before the very last steps in the IETF process. We have quite a good number of working group documents. These are the ones that are in the agenda that will be discussed today. They include the transport MBI, OTN, both young model for topology and the tunnels, layer 1 CSM, and encoding for impairment-aware WSON. There are also some working group drafts that will not be discussed today. First one is the alarm module. Actually, there has been quite a good discussion about this draft on the mailing list. It progressed quite well. We had significant improvements since the last meeting. If I correctly remember, we prepared a liaison also on this document, but I'm not sure it was sent out. We needed to double check this. And then we have a recently adopted draft, which is the FlexiGrid media channel, the young model, and the tunnel model on FlexiGrid, which is let me say part of the previous one, and the microwave young model. This passed the last call recently. It has been reviewed by the young doctors, and it's now ready for the IETF last call. RSVPT bandwidth availability. This document, unfortunately, has been there for a while. We had the OSPF-TE bandwidth availability, which was put on hold due to work that needed to be done in TIS. Now both documents are concluded, so this is the next document that we will last call. Other drafts that have not been changed since the last meeting: the tunnel model for WSON and the topology for WSON, as well as the info model for impairment-aware WSON. Liaisons, as I said, we just sent out a liaison to the study group 15 regarding the DWDM interface management and control framework. This was submitted in May, actually, but it was not delivered. So the ITU is expected to work on this to review the liaison, and next time they will be meeting. So this is it. We can start. Anyone willing to make comments on the agenda, add topics? If none, we can start with the first presentation from Italo. Just a second, we are loading from OneDrive. Okay.
Okay, thank you. I'm Italo Busi. I'm co-chairing together with Daniel the design team of Transport MBI, and we are going to give a status update since the last IETF meeting. Okay, a quick recap about our goals and deliverables. So the intention is to analyze how the IETF young models are applicable to transport networks at the MBI transport networks, and we work on mailing list and conference call, and we have a GitHub where we track the code and the open issues. So our deliverable up to now is the draft, which is doing an applicability statement for transport MBI. So analyze how the IETF YAM models can be used to control a multi-domain OTN network. And in this draft, we provide a description of what is the scenario, a reference scenario for a multi-domain optical network, which is in the description of what needs to be done is independent from the YAM model. And then we go into the details to see which YAM model developed by IETF are and how they are used to meet to control that scenario. And we provide detailed code examples of the JSON that will be exchanged of the different MPIs. And on the the focus of our draft is the MPIs between the MDSC and multiple PNCs, where we have to describe the topology abstraction, how the PNC extract the topology, it is controlled to the MDSC, how the service is configured for an end-to-end multi-domain scenario, and how protection and restoration, and also we have added also service modification. What happens when the service is modified from protected to unprotected, for example. The reference network is outlined here. So we have different customer equipment outside of our control. The access links are supposed to be 10 gigabit access link. And we have the network is partitioned into 3 different network domains. And for each network domain, we have a PNC. So the scope of the draft at this moment are the 3 MPIs between the 3 PNC and the MDSC. And the current version is analyzing in details. In the version 02, we are analyzing in details down to the every JSON code. What is the audio topology and the audio 2 service and the EPL over audio 2 service configured over the PNC1. We need to complete the example. What are the models that we are analyzing? The T topology and tunnel model, which are under development, almost closed by TIS. The OTN topology and OTN tunnel under developing here in CCAMP, and we are also using an individual draft that has been submitted to CCAMP for the configuration of the Ethernet client. So how you set up an EPL, how do you configure which port has to be mapped over the audio tunnel? And we have all the work we are doing on JSON. The JSON is validated, so we have we use some tooling to check that the JSON code that we develop is valid JSON and is compliant with the YAM model that has been developed. So the JSON code is correct. It's not there are no bugs, and we have some tooling here. We are that are used to check the JSON code, and what we are also discussing is when you develop JSON, you have very long lines. And we have some tools to fold this text to stay into the 72 character width. This is a requirement by Internet Drafts. And we have noticed that there is a working group document, actually an individual document to NetMod working group to fold and unfold the text. And we are looking at that and see how it is applicable to our work. And we have some more details. And we have a question about that, whether this validation code validation is applicable to a broader scope than just transport MBI JSON code. So whether or not to take the Appendix Bs from our draft and move into a NetMod, the working group draft, to make it available to the broader community than just the design team. So everybody who writes a JSON code can check that his code is in line and compliant with the YAM model. Open issues. So where we are at this moment in time, we have to, first of all, try to prioritize what are going to be the next examples. We still have a lot of work to do in the details. So we have to describe EVPL and multi-point Ethernet services as supported by OTN. We have some description to do. How do we manage the multi-access function access links? So some 10 gigabit access links, which can be configured to be OTU2, 10 gigabit Ethernet, or STM64. So how do we manage that? How do we control protection restoration, and how do we modify the service characteristics? We need to give a priority list of all these items. And one other big issue we are discussing is how do we identify the topology elements. So there are many identifiers defined in HURS and T topology models, and we have some different ideas, and we are still discussing them, trying to understand how to populate this identifier, which being compliant with the requirements that we have in this draft. And during this discussion, we got some questions from people about whether we should not propose a sort of a best practice to TMBI. So the standard model is very flexible. People can write down, can put any identifier schema, but the question is, can we recommend that on the MBI or a transport network, this is our best practice recommendation? And the question is, what about doing that? And the second question is whether this best practice we should not document and have some URN registration to say what to allow the client that reads the identifier to understand what type of rules has been used to build the identifier. And these issues are all tracked into the pull request number 10 on our GitHub. So we can go better. Then the next steps is to work. So we address all the open technical issue. We still have a pending issue from the last time. We want to align the text with the T tutorial developed by TIS. So checking where is the duplication or where is some text in our document that should go there, and make sure that we avoid the text overlapping between the two documents. We need to complete the examples for the existing service like ODU and EPL and other client to cover also the other domains, not only domain number 1. And we have, based on priority, add the new examples. And we have to, as we said, we have to discuss both priority order. And we are planning to have a face-to-face meeting. When we did the slide, we didn't know the time. This morning, Daniel announced we have found the best slot for the participants. Is going to be tomorrow between 12:30 to 1:30, and we are meeting by the IETF registration. So anybody who is interested to join is more than welcome. So that's completion. I don't know if any people has input, especially on the priority and the open issues.
That was maybe we can take this opportunity to discuss together open issues and priorities.
Hi, this is Captain Juniper. I have a question about the picture you showed over there with the multi-vendor network. Not this one, the other one. So, how do you define vendor in this environment?
Actually, what we did in the design, in the document, we were not saying that every network domain is a single vendor, but it's an underlying assumption. Basically, the idea is that this set of network elements are controlled by a single controller, which is PNC1, this one by a second PNC3, and this one by PNC2.
So it's not necessarily different vendors,
not necessarily
different SDN domains.
Exactly, yes. For our scope, it doesn't. That we don't care. In practice, we expect these are 3 different vendors, but
then the question is, let's assume that we have those routers over there. They have let's say, an alien wavelengths interface communicating through the things. So are they then automatically supposed to be in a different, controller domain?
These one are in the customer domain. Yes, these are outside of our. It's above here. It's above the CMI because the MDSC is controlling. So these are the customer edge equipment.
So a transponder, in your definition, is a customer.
No, here the transponder is on the box because it's OTN. So here the access link is electrical, is not adding wavelength. In this applicability statement, we focus on OTN, not on optical networks.
Well, OTN has also optical
components. Layer 1, you're okay. Yes.
So,
good question. Layer 1.
Yes. Define one. I mean,
okay.
I think it should be a little bit clearer what those boundaries here means. Because let's say when I'm looking at this, I kind of understood that this should be kind of controller domains.
Yeah.
But the way it is often described is kind of an OTN or technology domain. If you look at it, it appears to be a technology domain, which is not necessarily the case. So I think we should grasp a little bit better what domain really means. So again, if you put a transponder here, it becomes immediately obvious. Or if you would replace the routers with an SDH
Or can be
connect or
this
something.
This link can be a 10 gigabit Ethernet, can be an OTU2,
Yeah.
or can be an STM64 or a fiber channel link as well.
Yeah.
We are running. Yeah, can be anything. Yeah,
Can be anything.
and can be a multifunction, some link that can be reconfigured. So, for example, if this one is STM64 and this one is flexible when you set up, and this one is 10 gigabit Ethernet, when you set up a service from here to here, is an STM64. But if you go from here to here, is Ethernet.
Right.
That's the point. That's
Yeah.
one of the items that we have to describe. And in that case, what you do, based on the service that you configure low-level details on the file.
So, okay, that brings me to the second point then in the model. So, in some cases, the kind of, let's say, border of this network domain may go through the same node, not through a link.
Sorry? Oh, the trip-to-trip configuration, you mean?
Yes. So, if you would think, for example, let's assume, let's get a little bit away from router or not router, but let's assume you stay on layer 1 and you had a Sonnet cross connect with an OTN interface facing into your WDM, right? Here, yeah.
Mm-hmm.
So then there is only a boundary between Sonnet and OTN.
Mm-hmm. Yeah.
Plus, there's a boundary within the OTN.
Yeah.
So
Okay.
and let's say this kind of model always assume that there is this the boundary is on a link basis. And what I see in reality, it's in not always, but often it's on also on a kind of component or.
Well, I think one point, the rough is assuming that all these nodes are audio switching capable nodes. So we care about, and then we maybe need to be more clear, we care about audio layer at this moment in time in the applicability statement. And the other assumption is that this link is configured up to the OTU4 level. So all the transponder, all those issues are solved by means which are not controlled by the MPI. So what you have this OTU4 set up from here to here, which provides to the MDSC a capability to set up audio over this audio link.
Look,
and then what we have is also here is the boundary, well, as you said. Here, if it is an audio 2, that's easy. So you have an audio 2 coming here, and then you have to carry the audio 2 through all the network and delivering audio 2 here. That was a simple case. The most complex case, for example, and that's where we have an individual draft added, is that when you have a 10 gigabit Ethernet coming here, then you have to say that the audio 2 tunnel that starts from here and ends here, it's actually carry the traffic coming from this Ethernet port, and how this traffic is it. So it's Ethernet, it's port-based classification, or it's VLAN-based classification, and that's where we had the needed for the other draft, which is not the OTN draft. It's this draft. Yeah. At this moment in time, we have only an individual draft, and we are analyzing that draft to solve that problem.
Okay. Well,
Gort, this is Young Lee. I have a question for you. What do you mean by boundary can be a node?
so can we go back to the thing? So just as you mentioned, so all right. So let's assume the red link here would be Ethernet, and you would start your tunnel on the first element as 31, right? So from a technology perspective, somebody needs to do the mapping, and that will be
you mean the layer boundary between Ethernet client and the OTN
somebody
server.
needs to be managed. You have two choices.
It's on this box, yes.
Yeah, so either it's on the box in the network domain, or if it is an audio 2 and it sits on the client bot.
Yeah.
So the problem is kind of the same, but the boundary is kind of in the middle of the box.
Yes. Already be
So
okay, it's somewhere in the box.
It's somewhere in the box,
Yes.
right?
Yes.
And
in the draft we said that one option is that these guys do the adaptation between packets and audio, then you deliver an audio. So, in this case we don't care because we don't see the adaptation. What we see is an audio coming in, and we switch the audio. The second case is this guy is sending packets, and then here we need to do adaptation between packets and audio.
you only don't care because in the first case, because
this one is outside
your domain, but you can
exactly.
also state, since it is producing ODUs, it's just yet another domain like this one.
Yes.
So by itself, again, it would be kind of a half domain
Yeah.
And we're back on the same issue. So, I think we need to figure out a little bit how exactly we want to shape. the
Okay, maybe we
domain.
can sit down and
Yeah.
look at the text in the draft of what we in details. I think all these issues are intended to be clarified in draft. If they are not, we can rephrase
But
what is not clear.
in the end, a domain is composed by all the nodes managed by the same SDN controller, right?
PNC, yeah.
So in the end, a node is either it's controlled by SDN controller or it's not. I've not seen. I don't think it's common to have nodes which are managed by different controllers at the same time. Portion of nodes.
If you run it in, let's say, a router network, you have several CLIs. You can access your node. It's not one client. Well, we call it client, right? The controller. It can be more than one client accessing the node. So, what does it mean to be one controller? To give you another example, a famous, let's say, new thing is telemetry data, right? So it's collected by some controller. All of that data will be collected by the same controller, or at least a good subset, and you wouldn't care about any kind of network domain 1, 2, or 3. So it's very hard to define the term domain. So that's why I'm a little bit insisting in getting it right, because it's simple to say, oh, well, this is kind of something fluffy based on technology adaptation. Because it gives you a kind of a feeling of having it well defined. But if you think about an adaptation being the boundary, then the boundary of the network domain always goes through a node. If it is not the adaptation, if it is a link, right? So
But, I think that you are assuming that the boundary of the domain is on the technology. That's not what you are doing.
I took it as an example.
Okay,
I took it as an
okay,
example.
okay.
I'm not
Yeah.
assuming it. So, but I also want to say that the assumption that one domain is controlled by exactly one controller is equally flawed. So there are many controllers often accessing the same node. So some have only read access, some have read-write access. You have the old element management system kind of thing. You could screw up a lot of things. So it's really hard to define what the heck is this domain.
Mm-hmm. Okay.
So I have one comment about the definition of the terminology of domain, because actually different SDO, they have different definition even for the same terminology. So here we should use the IETF language. For example, at least in the IETF there are some drafts, they also have clear definition of the domain, so we can just reference to those drafts the existing definition of the domain.
Okay, Gabriele from Cisco. I have a two quick question. The next step here is to define also a domain for layer 3 and then manage it, but probably it's not the scope of this working
It's only
group.
the ACR. So the year 3 is outside of here.
Yeah, exactly.
Yeah.
But you could add another domain if you want. No, another
But
domain
it's
and
still
layer technology.
audio. No. This for this document. And if people want to do an applicability statement for IP, we can do, but that's not what we are doing now in the design team.
The next question is, do you have any plan to extend this work on DWDM?
Okay, good question. Not yet. Let me say this way.
Thanks.
If you want, we can work on that. It's just based by contributions.
I think that will be very interesting because you cover the transport layer.
Yeah. Okay. Thank you.
Thanks, Ito.
Hello everyone, this is Hao-Mian speaking from Huawei, and I'm presenting the two drafts, actually young model for OTN topology and tunnel respectively. And the first draft is about the OTN topology. And this is the 03 version, and we update a few terms, including both the text and the young models. For the text change, actually, we highlight the augmentation needed for the OTN technology specific, because we are augmenting the T topology model, which is now stable and into RFC release. And correspondingly, we update the young model by augmenting to the latest model, including 3 different items, like the OTN specific attributes, the T bandwidth augmentation, and T label augmentation. So we so for the OTN attributes, we include some very specific terms like tributary slot, granularity, distance, index, and client-facing stuff. This is just directly augmented to the T topology lifts. But and the other augment to the bandwidth and the label, we have actually same group of parameters, but augmented to multiple places in the original Yang tree. And for bandwidth, we want to include the audio type and the corresponding numbers. For the label, and especially for the label start and label end holders, we need to include the tributary port and TPN and the TS, this kind of information to indicate the format of the label. And for label hub, we have same stuff, but in different organizations, in different shape. We only include the TPN, TSG, and the TS list as a string. Scroll down a little bit. This one is missing. Yeah, and for label restrictions, the range type is also requested, and we also bring the TSG and the priority. So this is what we want to augment to the T augmentation. But unfortunately, if you look at carefully here, actually we the attributes is fine, but there are.
Sorry, I'm trying to fit the screen.
Yeah,
maybe now it's better.
Okay, thank you. So for for the attributes is fine, but here we cut and paste what we have done for the T bandwidth and T label respectively. Actually, as there are many entries in the base model, so we need to augment everywhere the same parameter set and do it multiple times. So we received some comments on the mailing list talking about this issue, but I think this problem has been discussed when the IESG was reviewing the base model and also discussed with NetMod working group. So our augmentation is consistent with the outcome of this kind of discussion, and we also follow the guidelines that is provided in the T topology draft. So there is a special section tells you how to augment to this model by introducing those kind of technology-specific issues. And now it is done like this. Okay. This one does not work. Next page, please. Okay, so now from the time being, we think this work is technically stable, means that everybody are clear on what to be augmented, but there is a kind of readability problem, and we wish to discuss with the working group together with the young experts in the IETF. And now I think currently we would like to request for the WG last core or young doctor review to better handle the young issue in this draft, and we think that would be helpful.
Mahesh Jetanandani, Zorient. You actually probably want to do the young doctors review sooner than later.
Yes.
especially because
Yes.
you have so many questions related to it. Please send a request on the Young Doctors mailing list that the chairs can do that. You can even request an early review even before the last call, and I would suggest that if you have concerns, do that soon.
Yeah, okay. Thank you.
So just one question for clarification. You mentioned already that this is about ODU, but where do you plan to put the OTU, so to Motu of the model? So if it is WDM, probably it will not show up in the WDM side, and if it is not ODU, it will not show up here. Do you think
Yep.
there will be a third one, or how do you plan to deal with OTU?
Well, currently we do not have any specification to include the OTU. OTU is a data plane term that
Sure, but it's
associated with the audio.
exactly.
audio
So
term,
typically it's associated with the ODU.
Yeah.
So I would have had expected to see it here. But somebody could say, okay, it's part of the WDM, which is not my expectation, but I mean, would be equally possible there as well. But at least it should be somehow clear, maybe a statement or so, where to put the OTU. In particular, because there are extensions now for multiple OTU interfaces. So it would be good to know where to
Well,
find them.
at this moment, personally, I don't think OTU need to be configured by the Young model and Netconf, but we can discuss offline, of course.
Good point.
Okay. And the next, please. So the next draft is about the OTN tunnel. This is going together with the audio topology. And yeah, we gave we updated twice during the from the previous meeting, and including both the text changes and the Young model changes. So this one has compared with the topology one, this one has larger changes because we have the OTN tunnel Young, we have OTN types, we have an RPC specifically for the tunnel query. So we provide the corresponding description updated to be consistent with the latest model, and we also include the Young model changes in the same way as OTN topology. So currently we deal with the OTN Young, OTN tunnel Young, and the RPC and the OTN types separately. Next. And for Young augmentation, this is a similar issue with the OTN topology. We want to augment with some OTN specific attributes of the T bandwidth and T labels. And the shape and parameters are similar as the OTN topology. And the problem is also similar. Next, please.
Right now it works.
Oh,
It doesn't.
oh, great, it works.
Yeah, but
So already also the same, some repeating for the parameter list due to multiple entries of the T bandwidth and T label. And now we just noticed that the T tunnel model is still under working in the T's working group, and we now the current version is aligned with the latest version of the T tunnel, and we wish the augmentation principle can be the same as the topology augmentation. So I wish we won't have a big change on the T tunnel model, and also this augmentation is currently good. And for the OTN types, we didn't change the code itself, but we did figure out some issue that may be misleading. For example, the term here, tributary protocol type, we may think we rather use the audio type to indicate the meaning, because it's just define what is possible types of the audio signals. And some of the prefix need to also be adjusted. Currently, we have protocol-based and client signal-based, but actually, by discussing with all the others, we think this may not be necessary, and we need to combine a little bit, to simplify a little bit, and remove those kind of prefix. So, and the other issue is we want to align this kind of types with other models, especially for layer 1 CSM. So because we are carrying similar signal types, but we do not need to define separate identities for the same term. Like like for example, the STM1, we are currently using this one in the model, and we will going to change it with STM-1 to be aligned with the layer 1 CSM. And for the next step, I think, we need to, we may need further update according to the latest change of the T-tunnel model. I believe there won't be a big change. And also, we still need to further align with the RPC in past computation model. And we are working on that. And now the model is also available on the GitHub, and you are you are welcome to review. And we also would like to request a young doctor review together with the previous draft. And we wish to have the working group last call in the next IETF after everything is done.
Mahesh Chetanandani, have you looked at the Yang author's guidelines for how to write the model 6087-BIS in particular? RFC 6087-BIS.
For what?
So it has guidelines on how a Yang model needs to be written. So it has a security consideration section. I have not looked at your document in specific, but I would highly suggest that you go through those guidelines. Make sure that before you send it to Yang Doctors review, you have gone through the guidelines and met all the guidelines.
Okay, I will take a look at that. But I think the base model provides a very detailed guidelines on how to augment it. So we just directly put our parameters into that one, and that fits.
So because like some of the name changes that you made are already set in those guidelines, and that's why I thought you may have already noted it, but I would suggest that you take a look at the guidelines.
Yeah, I think that's a more a technical term. Right?
Yes, and another thing before sending the draft to the young doctors for review is to fix what is still there, because I mean, if we change something after the young doctors review, we might need to go for another round.
Okay.
And the T-tunnel model is not yet past the working group last call, if I correctly remember. So we might have changes also there. So
this one, I think this one can go after the previous one.
Exactly. The T topology should be.
I think that
it's
is
in the editor
stable.
queue, if I correctly remember. Yeah. While the T-tunnel model is a little bit behind.
Yeah,
we can start from the topology.
Yes, right.
But please,
I will do the homework.
Check the guidelines.
Good afternoon. My name is Young Lee. I try to present layer 1 CSM data model. Yes, I think this draft was adopted in the last IETF meeting, correct? Yeah, and then I went to MEF Q2 meeting and to present this one because CCAMP has a liaison with MEF, layer 1 CSM work. And actually, it was very well received. They like this model because they don't have a data model for layer 1 service attribute. And they, I think, along MEF comment and also Tom Patch's comment, there was suggestion to separate out service types from the main module. So that's what we did. And actually, we named the service type layer 1 MEF service types because we got this directly from service attribute defined by MEF. So I think, as Hao-Mian said, if another client signal is need to be defined, it will be something else, not MEF, but layer 1 or whatever, and then some service type, so that we can refer both of them if any module need those references. And we had pretty heavy traffic from Tom Patch for last 1 month or so, maybe last few weeks or so. So I don't want to go details on that, but the indentation issue and separation of service type, references, time interval, etc. So and also he wants JSON example so that readers can understand easily. So we actually accommodate all of them. So this is a current Yang tree. So we have access, unit list, multiple of them, and UniID and protocol encoding and optical interface, which is actually coming from MEF's service type. And then we define services, instances. And MEF guys said, their service identifier is a 5 tuple. I don't know why they have 5, but they wanted to add all those 5. Layer 1 VCID and endpoint ID, another endpoint ID, and UniID and in both sides. So that's what they define service. It's a little bit redundant, but that's what they do. So we accommodate that. So one pending issue is readability of L1. I think Tom Patch in particular said L1 is hard to read. What is L? What is 1? So he suggested something else, but I said I'm going to ask working group if this is worth to change, and which I prefer not to change because it may mess up other stuff. I don't know, but so if anybody prefer changing name just because it's hard to read, L1, but this one has been convention for L1, L2, L3. So I just want to follow convention here. So I don't think it's a big deal, but some people make big deal out of it. But I just want to ask working group, if you prefer to change, please let me know so that I can at least think about it. But otherwise, I'm going to stick to that. Okay. And default value for performance monitoring period, I think 1 month be a good default. Actually, he suggested, so I kind of use as a, I haven't put as a default value, but I think, you have a question?
Yeah, Mahesh Chetanandani, Zorient. Since I have worked in both IETF and MEF,
Okay.
and in particular, we have worked on MEF services, Yang model.
Yeah.
I would urge you to look at the Yang models that MEF has published, and in particular, the service types they have already defined, and make sure that your model is aligned with that model.
Sure. That's a good point. Could you send to the list the particular MEF reference? MEF
Sure.
61?
It's MEF 58.
58. Okay. Thank you. Great. Yeah. So, and then performance monitoring period, 1 month. You have, yeah, sure.
And Dieter Nokia, I actually support the idea to align this with the work that's going on in MEF.
Yeah.
Is it worth to send a liaison statement to MEF, or is there a liaison in place right now already?
Yeah. Yeah, they sent, and then CCAMP, maybe you can send back that, we want to be consistent at least, It may not be end up same, but at least, don't overlap. Yes. And performance monitoring being 1 month default, I think this might be a good thing, but we don't want to impose anything to the model, so we haven't put that as a default value, but also min-max value. And the JSON example is provided here just to configure how to do that. So this is just updated in this afternoon. So I think I take Mahesh, right? Yeah, Mahesh's comment. Actually, I'm going to MEF next week. Are you going? Okay. Yeah, I'm going to ask, at least look at your reference so that whether there's any duplication, and we take it out. Okay. I think that might be the biggest issue, I guess, right? So far. And I think because of, thanks to Tom, I think document is now putting a lot of stuff, references, security sections, and consistency for the, all the logistics and so on. So hopefully next one more revision after MEF meeting, this might be ready for working group last call and move on. That's also a desire, but it's up to the working group chairs. Okay.
Any other feedback from the MEF on your presentation? I mean, informal ones in addition to the liaison.
Yes, actually, they like this model because MEF currently don't have data model for layer 1. They have info model and other stuff, but I talked to service committee and LSO committee, both seems to like it. So we may want to formalize it.
Regarding the name, I mean, when it becomes an RFC, it's a number. So the name of the draft will be dropped. So
yeah,
I don't see a big issue.
No. Okay. Right. Any other comments?
So Yang, can I ask one comment? So when we talk about layer 1, layer 2, layer 3, which reminds me to ask, where's layer 0? I mean, if this job, this should also cover both layer 1 and the layer 0, or only, defines layer 1 service model?
Only layer 1. And I asked MEF, are you guys plan to have layer 0 service? They said no, because there's no IETF spec for layer 0 services. But doesn't mean we cannot do it here. But it might be a little bit controversial, I think. But we can do it if somebody want to do that.
Just for curiosity, is there anywhere a definition of layer 0?
No, that's the problem.
Yeah, I mean,
yeah, you have to define.
But everybody knows yes, layer 0.
Everybody talks about it, but I think the numbering ends with 1. Ground 0, layer 0.
Yeah, so that's out of scope of this document, so I don't want to answer that. Okay. I thought I was done, but I have another one, sorry. Yes, this draft is information encoding for WSUN impairment validation model. This was adopted actually after last IETF, I believe, and the scope of this document is encoding, general encoding for impairment data for WSUN that can support multiple protocol enhancements. So OSPF-T and RSPPT and PSAP could use this encoding defined here. So changes from previous version was not much, but add a few sentences to make it clear the right reference and right wording. So we basically extending 7579 connectivity matrix defined there to include impairment data. Likewise, a resource block defined in 7581. It's been around, but just accepted. But I think document needs some section that says how specific protocol can enhance this generic encoding. I think that's actually your Dito's question, how to use this one in the specific protocol encoding. So we are going to add that section later, which is due. But I have one generic question for the chairs. I think generic encoding was developed for WSON to think that whether we need generic encoding or not. So this means after this draft, we have to have maybe 3 separate drafts, which is specific to OSPFT, and then if there's RSPBT enhancement and maybe PSAP. PSAP is actually a separate issue because it's not in this working group. But do you think it's worthwhile to put it here as a one place? But we specify how to apply this generic encoding instead of having another 2 documents which may take another year to progress. Rather, I suggest to put it here so that it's the one shot. That's my suggestion because this might be now getting more important. Impairment is getting more important in optical. So GMPLS needs to support that. I'd rather do it in this document rather than having...
There's no particular rule. I mean, either you can have different documents or everything into the same one, into the same...
Okay, that's good. Any question?
Obviously, the difference is that this is a working group document, so all the encoding needs to be driven by the working group. On the other side, if you decided to start a new work as individual contribution, it's the authors that decide what to put there. This is the difference between putting it here or starting new individual contributions. But this is...
I don't understand what you say.
If you start a new document, basically you write there whatever you want.
That's right.
If you wanted to add the new text to a working group document, this is something that needs to be agreed by the working group before being put into the document.
Yeah, I agree. Yeah. Okay.
Hello, everyone. This is Amy from Huawei. I'm going to present a young data model for microwave topology. So, an overview. It's a young data draft data model to describe the microwave topology, and we assumed basically just 2 use cases at this moment. For the topology model. One is for the resource management. For example, we could report the microwave link frequency or something else related with the microwave link, so which could enable you to have a home network view. And then second use case is about the path computation, because the link will have a unique feature that the bandwidth will change from time to time. So understand the microwave bandwidth is quite important for you when you set a path computation across the microwave links. And aside these 2 use cases, we also want to use this topology draft to answer a few questions. First one is we have a microwave interface young model, which is close to IESG NASCO. And so we have received the question, what's the relationship between this topology model and the interface model? So we will try to answer this question. And the second one is how about the relationship between the Ethernet topology and the microwave topology? Because Ethernet is one of the main client service over the microwave link. And then the third question is how that's former one. Yeah. The third question is how to represent a single microwave link and the multiple microwave links.
I'll scroll down for you.
Okay, thank you. So that's the changes in this 0-1 version. We add some new data node definition. One is for microwave unreserved bandwidth. So this is for past computation use case. And then the second point is that we add a mount point for interfaced model. So I will explain more about this point. Regarding the unreserved bandwidth, so we are thinking about how this unreserved bandwidth is calculated. So there might be two different understandings. The first one is that we use the nominal bandwidth to exclude TDM and then subtract Ethernet, and that's the unreserved bandwidth. But as I mentioned about that, the bandwidth will change from time to time. So another way to do this calculation is to use the current bandwidth to do this calculation. So in such a way, this might cause some ambitious understanding. So we're thinking maybe a better way is to define the reserved bandwidth from another side. So we might use the microwave reserved bandwidth to represent how the TDM and plus the Ethernet bandwidth been reserved on the microwave link. And then we are trying to answer the questions we are listed in the first slides. First is how is the relationship between the topology model and the interface model. We actually do some search among the related RFCs. Actually, in RFC 8199, it said that narrowing of the models allows for reusability of existing lower layer models by higher layer low modules, while limiting duplication of features across layers. But in 8199, it doesn't say how to do so. So we found more clues from 8345. It said this is about the topology, network topology model. So it says that the node, an example of the termination point might be a physical or logical port, or more generally, an interface. So this is very important. Then in net mode, there is a schema mount draft, which defines a schema mount. And this mechanism will enable you to have a set of young modules onto a mount point in the schema tree in some young modules. So you see, next one, please. So this is we define an interface route right here. And then with this data node definition, we have two options to mount with the interface model we defined. The first one, if we want to full exposure of the microwave interface, so we can mount the interface module directly. And the second option is that because the interface model exposes all of the details, if you don't want to so much exposure of the details, you could create another deviation models based on the interface model, then mount this deviation model to the interface route. So this provides the flexibility based on your requirements. But then another point we might change to this interface route is that this could be an optional feature. It should not be mandatory. So we will change this to optional in next version. Next slide, please. And regarding the Ethernet topology and the microwave topology, so we have some clues from the T topology model. The figure is from one of the T topology presentation, and it allows us to have separated server and client layer. So in two independent T topologies by using underlay and overlay. And this slide, please. So in this example, we will say we are trying to answer the question also combined with the formal second question and the third one. You will say that in the figure we have the one overlay topology, that is Ethernet topology, and the underlay T topology is in microwave. And in the T topology Ethernet layer, we will say that there will be underlayer features related data definitions to describe how this underlay link is supported by the underlay terminal and links. And then in the microwave T topology, we will say the related, the microwave related data node definitions. This one, please. And then another common use case for our is that we will use two microwave links to support a client services with much wider bandwidth requirements. So in such a way, we are discussing how to model in this case. So at the Ethernet layer, it will be same as the former case. The only difference lays in the microwave topology. So we will have the microwave terminal is supported by two microwave links, and we will use the TTP local link connectivity list to list all the T links terminated by this TTPs. So this is all defined by the T topology. So within this, I think we're just trying to say how we make use of the current statements in the draft. Yes, please. So the next steps is that we were planning to resolve those open issues. For example, the first one is whether we should continue use the unreserved bandwidth or reserved bandwidth, and then change the mount point to an optional feature, and then editorial improvement, for example, to explain how the topology and interface, especially the link in the topology model, is actually the link between the carrier termination in the interface model, just to be more clear how these two models are related with each other. And we will also update the appendix examples. So any comments and reviews are much welcome. And another information is that we will have an plug test, which will be hosted in HCISG-MWT in next January. So this model combined with the other T topology model and network topology model will be verified in the plug test. And then finally, we would like to ask for a working group adoption and to use this as a starting point to define the topology model for microwave.
Here, Briskin Huawei. So we had some discussions about this modeling, and basically you mentioned that, say, you can split into two independent topologies, overlay and underlay, right? So overlay and underlay, they are not independent topologies, and they are related basically in a way that tunnels in the underlay topology support links in the overlay topology, correct?
Yeah, that's right.
Right. So, so the thing is that if underlay topology is microwave, it means that the tunnels, not links in microwave, support links in the Ethernet topology. So the fact that it's just one hop tunnels, it doesn't change anything. Okay, conceptually it's still tunnels. Okay, that support one hop tunnels that support Ethernet links. And the TTPs in the microwave, right? They kind of coincide with the LTPs in the Ethernet. Okay, so I would like to have it to make it very clear basically, because it's kind of obscured. It's not very consistent with our T topology story.
Okay, so actually the one of the formal discussion we have the options with put Ethernet and the microwave into one topology, but I didn't check with the latest T topology because what I referenced is in a formal presentation slides. So I'm not sure if it's not allowed in the current draft. But if it is still allowed, I think we will still prefer it in such a way because it will be seemed more clear.
It's not about, first of all, T topology hasn't been changed for quite a while. It's ready for publications. It's about to be an RFC. Secondly, it's not a topologist relationship. It's actually a server-client relationship when the server trail supports a link in the upper layer, the client layer. Okay, so in order to carry Ethernet frames over microwave connectivity, it means that you have a tunnel in a microwave network that supports link in the Ethernet.
Yeah,
okay?
yeah,
So we never
right.
had a situation where a link in one layer supports a link in the client layer.
Could you go back over to the figures? And maybe from one.
This one?
Yes. So actually, in the current model, we are trying to use the Ethernet link, which is supported by the microwave terminal. Yes. And the microwave terminal is supported by the microwave link. Yeah. Yes. Yes, that's right.
Hi, Luke Berger. I was going to actually, I'm coming at it from an opposite direction, but almost similar comment. What part of this is microwave specific?
So could you go back to the tree? Yes. Yes, okay. That's right. So we have the frequency, channel separation, and the nominal bandwidth. I think the important thing is for bandwidth, nominal and the current. I understand there's some T bandwidth in the T topology, but it doesn't reflect how the bandwidth will change from time to time.
How's that different than any variable bit rate media channel?
Yes.
And you can, I'm using the term media channel because that has a connotation of very high data rate, right?
Yeah.
But guess what? It also applies at very low data rates for other RF.
Mm.
It seems like this is a general concept, and I've looked at your draft a couple times, but I can't say I'm an expert on it. It's, think of it, I've just skimmed it.
Mm.
But it seems like there's a lot of good stuff there, but it's not microwave specific.
Yeah.
So
what's
I think you're just talking about, a variable bit rate media channel.
Yeah. Regarding the bandwidth, that part is the variable discrete media
But
channel.
even if you started putting in signal parameters, signal strength parameters,
Yeah.
that applies, anything that's basically doing interesting RF modulation, and we're doing that in all sorts of media these days, from very low data rates to very high data rates. So it would be, it's good work. I just think it should be made applicable to all of those types of channels.
Yeah. So will you suggest to go to the T topology or another one?
I wasn't. No, it's too late for that. I mean,
Yeah,
it needs to be its
yes.
own document.
Yeah.
I'm suggesting replace the word microwave with variable bit rate, or
Okay,
or
could be done.
let's think about what the right term is,
Yes.
but make it so that it can be applied to any of these technologies.
Radio.
Yeah, right. It
Radio.
applies to radio. It applies to optical.
Yes.
talk
I
about
agree.
opposite.
Radio might be.
You mean just to try to generalize?
Yeah. Why not?
just changing the name to radio.
I mean, it's almost like you do a name change and you're like 80% there, maybe 95% there. I don't know. We got to think about it a little bit, but
Yeah. I think that's a good question. We just change the name to radio.
I don't, yeah.
Okay. Good afternoon. I'm Sergio Bellotti. I'm speaking on behalf of the other co-authors to update regarding the draft related to the interworking of GMPLS and centralized controller system. Okay. The motivation of this work that has been already discussed is that try to understand how a technology like on the left part of the picture, in which we have GMPLS network, and now the scenario is changing, because on top of this type of network, it can be the controller hierarchy, like a CTN, and this impose the question mark about the interwork, about the set of protocol that is managing one and the other network. And the intent of this draft is to make understandable how these two technology can interwork each other to operate the network. With respect to the version 1, okay, we added two co-authors. The abstract has been polished to make clear the sense of complementary between the two, the GMPLS network technology and the SDN controlled network. There is a more detailed description about the regarding the usage of netconf resconf in conjunction with the IETF young model in case of multi-domain scenarios. Has been added a path computation section that has been updated with more focus in case to underline the manner in which is calculated optimal path computation in multi-domain, and use path computation model as provided in TIS to manage the limitation in case of the abstraction between the hierarchy controller. The paragraph on existing GMPLS control plane is being improved and has been updated also the reference. This is the picture that is describe the topology scenario in which we have three levels. There is the network neighbor level with the local resource discovery with basically LNP protocol. We have network level with the topology discovery with flooding of information among needs, with typically provided by link state routing with OSPF or ICS. And then there is the third one that is the possibility to have topology based on PCE controller to any relationship with the interaction between PCE controller to any.
Actually, it's quite common to have routing protocols also for interface type 3, right? SDN controllers passively listening to SPF, IS, or even BGPLS.
Between controller?
Interface 3.
Yes, interface 3 between PCE to any.
It doesn't have to be only PSEP or netconf. It could be also IGP or BGP.
Okay.
In theory, BGPLS is supported by optical.
Gabriele speaking. I don't think so. There is a BGPLS for optical. There is no. You should provide a bunch of parameters to share on BGPLS. There has been probably 4 or 5 years ago a draft from Stefano Previdi, and then has been dropped.
By the way, IGP, yes.
Okay. Okay, this is the table that is presenting the case of service provisioning. We have different 2 points. There is the step of the provisioning with path computation, path establishment, and the update of the database, and the mode. And we separate the different mode in which we can obtain data. So basically, there is the case in which traditionally with GMPLS control plane, we have distributed control plane with path computation based on OSPF, with path setup based on RSVP signaling, and the resource update is made again by OSPF. Then there is a mixed centralized path computation and distributed signaling that is in which we can have the path computation is provided by it can be provided by PSEP and or in case now with the SDN scenarios with the netconf, resconf protocol that can obtain topology and then provide path computation based on the topology that is obtained. Then there is the path setup that is distributed signaling, so again with the RSVPT. And the resource update can be or based on OSPF or again with PSEP, LS, or netconf. And the third case, it is the centralized case in which, okay, yes, we adopted the term centralized signaling with centralized path computation. Maybe centralized signaling is not correct term. It means the provisioning. Because in this case there is no distributed signaling because there is just the interfaces between controller and the nodes, and so you can have path computation based on PSEP or netconf, and path setup again with PSEP and netconf. In this case, for a path setup in case of hierarchical controller. You can use, for example, tunnel model database to set up the path. And the resource update is again provided by OSPF or PSEPLS or netconf. And we have updated the reference for of the different recommendations.
Just a minor comment. It doesn't make much sense to have interface 2 in the resource update with the centralized signaling, because what's the point in nodes speaking with each other if all the provisioning is done centralized?
You mean OSPF? Yes, you're correct. Okay, so next step, we receive support in the different meeting, the previous meeting, about the coexistence and interworking, so the motivation of the work. Well, so now we are open to the suggestion about improve the document. What is the scenario that has been improved or added in the document? What can be the issue, and so that is worthwhile spending effort to underline in the document. So we are open to hear about the working group suggestion to improve the document. But instead, we would like to ask for working group adoption anyway.
Let's make a quick check. How many people have read the draft? Quite a lot. You want to comment before we close the polling or after?
I don't know. Lou Berger. I think this is interesting work. I'm mildly concerned that it's duplicative of other RFCs that have been published that just talk about, don't use the same terminology, but say the same thing. What's the RFC number? I'm blanking on it, but what? 8283. 8283. But more than that, I'm wondering, I actually I like the work, even though it's duplicative. We just have to do some deconfliction there. What about this as CCAMP?
It speaks about the GMPLS.
Yeah, and
it doesn't apply to GMPLS only. I mean, this is for sure something that
is, what about? I can't speak for my co-chair who may feel differently, but I'd be perfectly happy to see this move into T's and deconflict and it's informational, so it helps people understand what to do. So the IETF doesn't like producing those types of documents, but that's okay. We can produce them too.
Probably it goes even beyond the TISA because it doesn't necessarily apply to only traffic engineer networks. Beyond the
I mean, that is a the joke was just made. It goes beyond IETF, and I think we've heard a couple of times this week where people talk about, we do solutions. We do tools. Great. We don't do solutions really well, and this is more a solutions thing. And I'm okay with. Again, personally, I can't speak for my co-chair who may feel differently. I'd be perfectly happy to see this move over to T's. And I mean, you got to make sure you're not saying exactly the same thing as another document. You can give a little summary and say, go read here for details. But
okay.
I just don't see this in CCAMP. Yeah, there's nothing that is specific technology here. It's all general principles. It's all, sorry to say this, it's a little tutorial in nature, but if it helps people get to implement the technology, I'm all for that.
Mm-hmm.
This is Young. You said 8283 PCCC. Yeah, PCCC, and this one, I don't think it's some overlapping content, but a little bit different, that's nothing but PCE architecture, but here is more than that, right? So I just want to clarify.
I think the concepts are, from a conceptual standpoint, the fundamental concepts are the same. The specific technologies being referenced are different. So that's why I think there's room for the work.
Right.
If it was completely duplicative, I would just say this is already done. Thanks. See you later. But that wasn't my comment.
Yeah, nonetheless, my point is I think this work is useful, whether it's a TIS or CCAMP or beyond TIS.
Mm-hmm. I agree. Yeah. I just don't think it's this working group.
Okay. So let's take this discussion offline.
So I think it's fine to take a poll of how many think this is interesting work and should be adopted somewhere. And then we can work with chairs and ADs to figure out where.
Okay. Let's conclude the poll. How many people think that this is an interesting work for the routing area? Quite a lot. Almost everyone that read the draft. Thanks. Thank you, Sergio. We need to be a little bit faster because we are quite late. Aumian? Try to cut a little bit.
Oh, okay.
Shorter
Okay, this
than
is
10 minutes.
This is Hao-Mian, and I'm going to already change the title and remove the term optical. So Young data model for transport network client signals. It's a 0.0 version, but actually we have some previous version. So currently in this version, we are categorizing the client model into two different branches. The first one is the carrier Ethernet, and we use the term as non-transparent because there are some thing middle between the client and the transport network. And the other section would be the we call this other transport network client signal, but we term this as transparent because the signal directly comes into the transport tunnels and without switching as a client layer. So we use the next, please. Yeah, we try to explain this kind of transparent and non-transparent by looking at the data plane features of the client signal. And for the transparent ones, we do not need to switch as a client layer. Therefore, we do not need tunnel model as a client layer, of course. And the topology model, we only provide the access links information that would be sufficient. And for this kind of client signal, the key feature is we only have point-to-point and port-based mapping, and the signal directly comes into the transport tunnel and comes out to the comes out at the other end. So the both ends have the same client signal type, rate, and coding. So that means we just need to reuse the transport tunnel and to carry the signal. And the typical example for transparent client signal includes the SDH, SONET, SAN, storage, and Ethernet PHY. So for this kind of client signal types, the parameters need to be configured, include both the client signal type and the access link information. So we need a mapping. Next, please. And the model here exactly shows how it is defined. So on the perspective of the transport tunnels, we need to understand what the signal type is by carrying here, and what are the access information by some other parameters. Next, please. And for non-transparent, this is slightly more complicated, and we just have one typical examples as carrier Ethernet, which includes EPL, EVPL, EP line, EP tree, and so on and so forth. So this non-transparent client signals have the following features. It can be P2P, MP to MP, or the access links have the same client signal type, still Ethernet, but they can have different rates and encoding, and they can be split into different transport tunnels. But this is more packet-based mapping rather than the port-based. So we can we need the kind of VLAN classification and operations needed, but there is no tunnel model needed again. So topology models are also similar with the previous one. We provide the access links that would be good enough, and we have a candidate draft on this one. And in the non-transparent client signal, the parameters need to be configured. Besides the basic ones, we also need to include some explicit Ethernet service features. Next, please. So here is what we specified for this kind of non-transparent signals. The first group is about Ethernet specific attributes. This is quite Ethernet specific, and then it is a basic information which means what is the name, description, and the types of the service, and finally is how it is accessed to the transport tunnel. So this is quite similar to the previous one. Next. And finally, there is a possibility that we can introduce the Ethernet client tunnel when we really need to be switched on the client layer. So the key features of the Ethernet client tunnel would be it's a hop-based, and we need to do this kind of client switching. So in this case, we need the topology and tunnel model for the client signals, and we have two candidate drafts here. Actually, they are augmenting to the T topology and T tunnel models respectively. And if you remember the previous OTN drafts, there would be issues, so we didn't update these two drafts this time, but we will update accordingly after the client signal YANG is stable. Next, please. So currently, I think we have reached some consensus among the authors that currently we shape the client signals by decomposing to transparent branch with a non-transparent branch, and we wish we have some kind of consensus in the working group. And if this is a good way to do that, but this is not the only way to do that. But if we agree on using this kind of categorization, I think we can still start talking about define the explicit model for this, and we can ask for working group adoption as a starting point. The model is available on the GitHub, and you are also welcome to review. Questions, please.
I'm going to make a comment almost verbatim to Luz. So basically, I think what we really need is a framework, a generic framework about how we map services on T tunnels, okay, which should not be dependent on particular technology. And whatever you do, it's very good, and we have to do this for specific signals and stuff like that here, right? But we need a framework that describes that here's the services coming from clients, and here's the provider tunnels, no matter which layers are, and how you map the tunnels onto the services. Okay, in general.
Yeah, I think your point is necessary, but I assume that work is done in the applicability statement draft.
It's not just applicability.
Yeah.
I'm talking about much bigger document. It's a frame. So for example, we discussed it with Luz co-chair with Pawan, a particular use case when a network operator wanted to control which backup tunnel protects which connection in an IP network. Okay, it's basically the same. It's the same thing. We have backup tunnels, and we have services in a form of connection that needs to be protected. Okay, so how do you actually go to the PLR? Okay, and tell here this connection should be protected by this backup tunnel, but these two connections by that backup tunnel. Okay, it's exactly the same like you would say. Here's how do you put the pseudo-wire signal or whatever private EPL on this tunnel or onto that. Okay, and on the tunnels you would consider all kind of T consideration, but on the place where the services are mapped onto the tunnel, it's just basically the preference of the client and the policies, which is very different. Okay, but it has nothing to do with a particular technology. It's all the same for different technologies as well.
Is this still for the how to say that for the device configuration, or
it's a device level configuration, but it is basically whether it's PE or whether it's Ethernet device or whatever. You want to say, okay, I provisioned on demand those tunnels, and now I want to map services. Just like, for example, in layer 3, they almost have this, right? They have the T tunnels. They have layer 3 model, which describes the service network-wide. And then they have another model, which basically says how do you put like a particular VPNs on the tunnels.
Yeah. This is a similar case. And we assume that the tunnel is there and how to put things into the tunnel, right?
Right.
Yeah, okay.
So this, in my opinion, is a very good work for tiers to get extended and to have like a generic framework for services mapped to the tunnels.
Cool.
We are cutting the line after Italo. We are very late.
Yeah, Dieter Beller, Nokia. Yeah, my understanding of this draft is that it is very technology specific. So it actually describes how to map Ethernet-related services into the OTN, for example. What I've also noticed is that most of the service parameters are not new. They're well known, and I'm wondering where those parameters are coming from, like, for example, the EVLAN services or port-based services, and also the CER and the other parameters. I'm missing references to existing work because I believe this is not new.
It's
Like
new,
this is work that has been done in other organizations like ITUT, like MEF, like
yes.
IEEE.
Yes, well, we are going to align it with other organizations. But Ethernet is only one example, but we have two young files in this document. One is for the carrier Ethernet as non-transparent. The other is for other clients like transparent. For transparent, I think it's quite simple and complete. But for Ethernet, we need some, alignment with other SDOs.
Okay.
So, yeah.
Yeah, thank you. I want to comment on what Igor was saying, and then would like to clarify that these models are assuming the topology model, tunnel model, but the client side is a very specific, technology specific, as Dieter is saying, because we have tried also in the past, and we don't have a common ground between the different layer 1 and layer 2, and also layer 3 will be completely different. So we focus on the specific, and then we say this is the technology specific things that has to go into the tunnel, and this is the tunnel, and the tunnel is just pointer.
Guys, we need to move on.
Okay.
Just a real quick remark. So basically, but if you want to
To move on with Igor's comment.
yes, just say. But if in general I have several choices, okay, what would be the way to say which tunnel I'm using, regardless of the client? Okay, maybe I can put the same Ethernet on multiple tunnels and or on several at once.
So what's your plan on that previous one? What happens next with that discussion?
Let's take these offline. Please, let's take these offline, please. We are 20 minutes late.
Only.
Okay, Gabriele Galimberti speaking. Okay, let's see. Here we would like to, let's say, next one. Okay. So basically, with this draft, which is still experimental, we would like to address a pretty simple problem related to the SSON network. Has been addressed some part of this technology by the 7699, 98, and 7792. What is missing, of course, is the definition of the carrier contained in the media channel, and then the signaling of the position of the carrier and the kind of the carrier we want to, the control plane may decide to use. Compared to the previous version document, there are very few changes. We just split the port identifier in source and destination port identifier, and then we reshaped a little bit the chapters. The novelty here is just not related to this document, but is more related to the information coming from the ITUT, the G Media, and the ONF, so that we see that, let's go directly to this slide. Okay, we see that the definition coming from ITUT is matching this slide, and they are defined the relationship between OTSI, the carrier, and what is carried by the OTSI group, let's say. OTSI group is the set of the different OTSI working together. And so what we discussed a little bit among some people that are in this room on the G-Media, and I believe we are not that far from the G-Media definition, apart the terminology, of course. So my opinion is that we should continue this discussion, and we should, let's say, keep very careful attention to what's going on in G-Media, because they are doing something interesting, and they are addressing the real problem that is made in this way, let's say. So let's keep all the details. Next step is to really follow the IETF and ONF development in terms of models and in terms of definition, just to make sure that we are still in line on that models. Of course, feedbacks and comments, but last but not least, I would like to have this document as a working document, because I think we need all together working on that and close this, let's say, weakening point of technology, or not address point of this technology.
Okay.
I hope give back some minutes.
Okay. Let's do a quick poll. How many people think we should work on this topic? The draft that has just been presented.
Basically, in the definition of and checking of this model. By the way, this picture is coming from 7699, so it's not the picture that is addressed by the draft. It's just a copy.
Let's change the question. Let's say, how many people think that this is a good document for a good candidate for working group adoption? Not that many. How many people have read it? So not that many, but none of them raised the hand. Okay, let's try to discuss a little bit more about that. I remember Giuliano was in favor.
Yes, Giuliano was in favor of this, but I think looking at what's going on in IETF, we should really consider this. If not, this document would be a different document with the same contents, probably.
Mm-hmm.
I don't care, but I think the time is becoming pretty mature to address this.
Okay, let's try to increase interest. Thanks.
Right, so this is a presentation about two drafts. I want to make it short. My name is Gert Kamon. It's about the WDM interface LMP07. You know, it's already around since a while. Again, LMP is really not about configuration. I always repeat it because it sometimes falls in this idea of using LMP to configure something. But this LMP draft is really about to understand what are the limitations between two nodes which are connected by a piece of fiber. So changes from the previous version, we basically just updated a little bit of references. And there's also, let's say, an interesting thing, because the draft has been kind of disputed in the past because there was no power monitor available in the ITU documents. While this draft, for example, asks to supervise whether let's say, light comes in or not. So what is the power level you really get on the receive end? So fortunately enough, ITU helped us there. There's now an optical power monitor as a function that monitors the optical power in one or more media channels, and that's thankfully the model for that. You see this little piece over here. These are the power monitors. So from that point onwards, we can use those constructs to say, okay, let's go with the draft. Power monitor is now defined. So again, what is defined in the draft itself is an extension of the LMP protocol, the existing one for WDM. So it has 3 different parameters: output power, current input power, and input power range, which is the acceptable input power range. So you see everything is about power here. That's why it was so important to get the 2017 version of G872. So that helps us here a bit. Now, again, next steps is we still need to update a little bit of the references, because there's so much things ongoing, particularly on the ITU side. And so we would like to ask to make this now a working group document based on the new definitions on G8.7.2.
Yeah, yes. Well, actually, I would say we will consider it for adoption when after the ITU has revised the framework, right? The framework document on DWDM interface management. Right?
Okay, let's keep it open until then. Okay. So you mean that's the one where? Well,
the one that passed, that is passed the last code.
Yeah. Okay. Next one is WDM interface parameter. It's kind of a companion draft. So this one talks about the Yang model that goes together with the LMP. Again, it has the kind of same changes, same updates. We're keeping them aligned. So the assumption is really to go together. So whatever the decision. Yeah.
Same comment.
When was WDM invented, by the way? All right. So this is about the Flex interface. It's really about the next further extension of LMP. So this is why we put it on a different draft about the Flex grid. So again, the same considerations apply. This is not about configuring anything. This is about figuring out what does the other end, remote end, supports when you connect it. Parameters to exchange, you see there's a lot more. Again, this is about the Flex grid. It's also, for example, a modulation scheme. So it aims to identify what is the other end doing. So don't go through all those details. You can have a look at the draft. So we are fixing here again some references. There's not much update here. We keep it aligned also with the other efforts in CCAMP, and we'll also focus on operational aspects, meaning it should be really simple to use rather than, let's say, solve everything in a very complex manner. Again, this goes together also with another draft, which is the Young model, and it also is about the validation of the impairments. Again, this is kind of providing a consistent way to operate wavelengths interface with netconf Yang. Changes, it's an update, so we are waiting for ITU to giving us the interface parameters to agree upon, and we keep it aligned. There's also an alignment with the draft IETF102-CCAMP-20180717-1550 IV info and the IV encode. So we'll probably follow the fate over there. So feedback appreciated. Also, if we need to wait for more input, let us know. We are patient, so I think these drafts are out since 2015, so we can stay there for another 3 or 4, 5 years. So.
It's good you're patient.
However, I read your slide saying that keep alignment with the two working group draft about the IV, but I want to clarify that I think the working group draft IV focus on the impairment between the SS and RS.
Yes.
But it seems that your document is focused on something around the ROADM only. So is it the same scope?
No, well, the scope is not the same, but they need to fit together, right? So also, for example, if you think about how do you describe the modulation scheme, which which helps you also to get the validation parameters. So you need to get it from somewhere. Now there are two ways. Either you have it, let's say northbound, you get it from your J.
Yeah, but be careful because some of the ROADM parameters will not be used in the impairment validation on the receiver side.
Yeah.
Just take care of it.
Yeah.
So we may not need that much.
We are waiting for our helpers to tell us what else we do not need.
I think we can discuss more on the list.
We are very good at waiting.
A request for the next presenters: if you could cut your time to say 80%, that would be appreciated.
Okay, hello everyone. This is Mark. I'm going to present update to this ISS extension for FlexiLink advertisement. Yeah, here's the history of this document. It was submitted last year and submitted to the ISS working group and present in IETF 19.8. And since then, we received some comments and at least two major comments here. The first one about home of this work. Their comment said this work should belong to this working group, so we take the comments and relay the document and submit to the second working group. The second one is about usage of the TRVs, based on which TRV to carry the FlexiLink attributes. So at the very beginning, we proposed to use the interface switching capability TRV to carry the FlexiLink attributes, but there's some point that they said that TRV is defined to describe the interface switching capability, and this is not about flexi switching. So we decided not to use that TRV and try to define new TRV to carry the FlexiLink attributes. So here's some terminology used in this document. The first one is flexi interface. So as we know, flexi can support bonding and channelization and subrate. So a flexi interface is a logical bonded interface that can consist of from 1 to 254 1 gigabit interface. And a flexi subinterface is a channelized interface of a flex interface. And so for the Flexi link, and that is a link connect to Flex interfaces, and also the Flexi sublink is a link that connects two Flexi sub interfaces. So here's the extension. I think it's very straightforward. We just define sub-TRV, which is called Flexi interface sub-TRV today, extended IIS reachability TRV. It is defined to describe the attribute of a Flex interface. For example, to carry the Flexi growth numbers, to the granularity of slot and available slots of an interface. And also this about Flexi sublink advertisement. Basically, a Flexi sublink can be considered as a normal Ethernet link. But sometimes, for some scenarios, it may be useful to indicate whether a link is a channelized Flexi link. Then the controller or the node can use that information to compute a path that is required to over Flexi link. So we try to we define or introduce a new flag to the link attribute TRV to indicate when flooding this link, it can be used to indicate whether this link is a Flexi link or a normal link. So about next step, so we plan to consider how to define a similar extensions to OSPF, and also we ask more review and comments on this draft, because this draft is very short and very straightforward. Just define extension to ISS to plot in the link.
The only thing is that I was expecting to see the framework presented again.
Yeah, we are working on that draft. Try to to address the comments and issues.
There were some concerns related to the framework. Have those been resolved? I've not seen much discussion on the list.
Yeah, the cars are actually are working on, but it's a bit slow. The
Flexi framework.
Yeah.
Quickly, Dave, please.
Okay, as fast as I can. So, just a question. My understanding of Flexi as it's defined by the OIF is that it would look like to any upper level protocol as Ethernet.
Mm-hmm.
If that's the case, and that is the case, why does routing need to know anything about Flexi? Wouldn't it just need to know the characteristics that it represented as Ethernet, like enhanced deterministic delay or something like that, and not need to know anything about the Flexi?
I think one example of this routing advertisement is for example, you want to use some protocol to signal the to trigger the configuration of channelized link to do channelization. For example, to slice some of the resources of a Flexi interface to form a
So you're using the routing to exchange characteristics about the Flexi configuration contrary to what the OIF
it can be done in
says.
that way. Yeah, it can be done in that way.
So we're contradicting the OIF spec so that we can get the Flexi configuration?
Actually, I think the channelization can be signaled by dynamic protocol. Also,
well, it can, but the OIF spec, as far as I understand, the OIF spec says that Flexi is not really visible to any layers above Ethernet. It looks to the upper layers like Ethernet. And now what we're saying is we're going to expose the details of it into a routing protocol to be able to configure it. So how do we reconcile that?
These are the concerns on the framework.
I'm sorry, I have exceeded my time.
Okay. No, I wasn't cutting you.
I'm cutting you.
So this is something that needs to be sorted out, but regarding the framework document.
Sure.
Then if
Sure.
we find an agreement on the framework, then we can talk about protocol extensions.
Okay.
Thanks. Shared mesh protection.
Okay, I'm Jia He from Huawei, and I'm going to present a new draft which defines a GMPS extension for shared mesh protection. So in addition to linear protection and ring protection, ITU G.808.3 defines generic aspects for the shared mesh protection. And based on that, G.873.3 also defines the protection switching operation and APS protocols for SMP at the audio layer. So this new draft is trying to update the RFC 4872 to provide extensions to the GMPS signaling to support the control of shared mesh protection. So let's firstly look at the SMP introduction. So in order to describe the shared mesh protection, we can use 3 characters to describe that. The first one, for the shared mesh protection, resources are reserved for the protection RSP at the provisioning stage, but the cross connects of the protection RSP are not established. And second point, the common link and node resources in a protecting LSP can be shared by multiple physically disjoint working LSPs. And third point, when the working LSP fails, the APS messages will be used to trigger the protection LSP and execute protection switching. So we can see there is a difference between SMP and SMR. SMR is already defined in RFC 4872. So the main difference between SMP and SMR is just the same difference between protection and restoration. That is shared mesh protection, we're using the data plane APS for protection switching, while the SMR will use the control plane signaling for protection switching. So therefore, we think it's necessary to distinguish SMP from SMR during the provisioning, so that each node involved behaves appropriately in the recovery phase. So we can see in detail the signaling for primary LSP and the secondary LSP provisioning. So first is about the signaling for the primary LSPs. We can see these updates. So for the primary LSP, during the provisioning, we're going to add a new LSP protection type, shared mesh protection. And also, in addition to S-bit and P-bit, in this SMP case, we will also set an N-bit. So the other things, for example, the association ID, or we will use the same way as SMR. We will add the association ID to indicate the secondary protecting LSP. And during the protection switching stage, which means after the protection switching, we also set the A-bit when we are using the parse message to refresh the working LSP. And then for the signaling of the secondary LSP, it's the same as the working LSP. During the provisioning stage, we also add a new protection type, shared mesh protection. And we also set the N-bit. And the other things, for example, the association ID, and we will use the same way as SMR. And in order to do resource sharing, we will also include a primary pass route in the pass message for the setup of secondary LSP. And then during the protection switching stage, which means same after protection switching. During the work protection switching stage, firstly, the protection switching will be triggered by the APS protocol in the data plane. So that is the main difference from the SMR. And then after protection switching, we will refresh the pass message with the O-bit set, which means we will the secondary RSP will become the primary RSP. So that is signaling of the secondary RSP. And as a summary, these are the updates to the protection object. So for the firstly, we will add a new protection type under the RSP flags. It's this one, shared mesh protection. And for the notification bit, the N bit, the operation bit, O bit, we will add SMP case. Currently, it's only mentioned the 1-to-1, 1+1 protection. But for shared mesh protection, we will also use these 2 bits. Okay, next steps. Since it's a 0 version draft, it's a new draft, we would like to get feedbacks from the working group level and see how we move forward. Okay.
Thank you. Yuji from Fujitsu, and one question. And is it possible to set up APS channel for protection path in this draft? My question is for the protection LSP here. We have a APS channel.
What do you mean by APS channel? Because we are sending APS message on the protection RSP.
Yeah, and my question is, APS is set up by this signaling, or this is another stage?
We are using APS for the protection switching. I'm not quite sure what's your question.
And in my understanding, that SMP is to have an APS channel for each protection path. And in this draft extension, APS channel is set up by the signaling or not. This is another one.
APS channel?
So Yuji, I would like to clarify. Actually, you mean APS channel here. It's a kind of data plan channel. It's already there. Yes. But this draft is not going to define, signaling to set up APS channel.
Okay.
Right.
Yep.
Yeah. They just use the data plan protocols.
Yes, we are sending APS messages. We are using APS protocol in the data plan to activate the protection switching, and we are sending APS messages over the protection RSP.
So from the control plane is just provisioning. Then the rest is done by APS.
Yeah, the APS data plane.
Okay.
Okay.
Dieter Bell, Nokia. Shared mesh protection is the most complicated protection scheme I've ever seen. I guess what we did in the past when we defined signaling or started to define GMPLS signaling extensions for mechanisms, we developed a framework document that also described the mechanism. It also described how it's applied, and it also described scenarios how it should be, how it should work. I think this is required for this protection scheme.
You mean we have to add the application scenario for the shared mesh protection in this draft? Is that
no? I think we need a separate document, a framework document that describes the shared mesh protection mechanism, how it works, what the motivation is to define signaling extensions for setting up or configuring the network elements that are part of shared mesh protection group. Because I believe that in the shared mesh protection group, all the network elements that are members of this group need to be configured. It's not sufficient that you actually establish a signaling session for the primary and backup LSP and configure it and configure the network elements only along these two paths. I think configuration or reconfiguration is also required when you establish a new service in the other network elements that are not along those paths.
Basically, when you add or remove LSPs from the group. Another thing, which is probably going to be Pavan's comment, this is a generic mechanism. It's not just for GMPLS, right? If I correctly remember, there was a shared mesh protection draft in MPLS. It was...
Yeah, there is one.
Yeah, so irrespective of whether, as Dieter said, there's another document or not, the protocol at the core of this document, it's a simple extension for a generic recovery mechanism. So you know where I'm going with this.
Mm-hmm. It's nice that you alternate with Lou. Last.
Oh, just a question. If okay, I can understand the request from Dieter to have more details on the framework part of this mechanism. The question is whether it has to be a different document, considering that ISG has more concerns with frameworks, or whether to put in this document rather than on a different document
actually,
reduce
this
the number of.
draft is a very small one. We start with trying to update 4872. It's a very generic one. Yeah. But if you're regarding ODU SMP, actually, we need more to config. Agree. Thank you.
Thank you. Let's see if there's something generic here.
I am not here to talk about GMPLS, T's, CCAMP. No, it is CCAMP. So quite seriously, this is, as we saw at the last meeting, there's this, I think we've moved beyond experiment, but there's this move of taking some documents out of the what was previously the MANA working group and bringing it here. Why? Because DLEP is just LMP with 4 letters. I mean, it's the same protocol. It's all about media channels, but the media channel here is focused at the RF layer, but it's the same stuff. So I'm talking about work that I've been, it was actually started by other folks, but I got involved with and been helping out with. So we have 4 documents in the MANA working group that are post last call. 3 of them are with the co-authors on that first page. The second one highlighted here is actually authored by 2 people sitting in the back of the room, but they're all post last call. We did have one sort of rendered a little weird. There was one technical change that we thought it was important to mention, but it still is proceeding. The technical change was basically the comment came from actually doing an implementation of the protocol. Strange thing is, we're the routing area, and we actually try to implement stuff before we fully standardize it. So that happened here, and out of the implementation, recognized that there was an inconsistency in how we did our definition of sub data items, sub TLD, sub objects, whatever you want to call it. It's all the same thing. In the first order sub TLVs. Again, data items in DLEP had TLVs, not sub TLVs, by definition were unordered. And we did our sub TLV definition ordered. And that was inconsistent. And because of that inconsistency, it actually meant that we couldn't just reuse the same mechanisms and the same parsing code and the same structural elements for describing packets that were used in the rest of the implementation. And I say we here, I had nothing to do with it. It's actually David Wiggins over at MIT. And because of that, there was a comment that came back, went through it. We said, okay, this is the right change. We discussed it on the list, and everyone said, yeah, this is a really good thing. And we made the change to allow for unordered. It had some consequences on the contents of the sub data item. That's it. But we're post last call, and we expect that to be any day now, come out of the Shepherd hopefully soon. We have some other documents that are still in flight. Right now, they're identified as MANA working group documents. After this meeting, we'll find out whether they continue as MANA or CCAMP. The ones that are really active are focused on credit-based flow control. Remember, I said this is really different. And what we're doing here is we have credit windows between a router and an attached modem, and there's a different flow control mechanisms. This one's a credit one. The reason that we use credits is the principle is it allows for highest utilization of the link. With, let's say, a pause-based mechanism, whether you're talking about Ethernet pause or control plane-based pause, you're saying stop, and you have some time to say restart, and if you don't get that timing quite right, you end up with gaps that are unused. So we want to try to have highest utilization possible, and that's why we have credit-based flow control. We had a bunch of discussions about how to structure these documents because we had some core mechanisms that were being defined and then being used at the time just for packets identified really by flows identified by DSCPs. And we wanted to say, well, maybe that's not the only way we want to identify them. We want to identify them also by Ethernet. And tomorrow, I know Rick has some other way he wants to identify things. He hasn't told us yet what they are, but now we know he wants to do that. And what we agreed on was to break out sort of the common reusable pieces into one document, and then have other documents that say what's the actual mechanisms you're using on a particular session. Like LDP, DLEP has a stateful peering relationship, and you know what your peer does. And we're saying at a time we want to be able to indicate whether or not we're doing DSCP-based flow control or Ethernet-based flow control. So the core mechanisms are in the DA credit extension. There's really two interesting parts to that. The first is a traffic classification construct, which is how you build out your traffic classifiers. They have some identifiers with them, and then some data items, sub TLVs, which describe the actual traffic. That's one piece. The other piece is the mechanisms to do flow control and using credit-based flow control windows. So that's in the first document.
Rick Taylor, I'm just going to jump in at this point. It's a good document. It's a huge step forwards from where we were before. Having just gone through it again just now, actually, I think we should probably split the traffic classification and the flow identity part out from the credit windowing part. The reason being is there was a working group document kicking around, and it's been kicking around for 6 years now, which is Stan's old credit window draft, which was credit windowing without flows. And I know there are people out there who want to do credit windowing but don't care about the flows. Well, and the counter argument is I want to do some stuff with metrics and flows but don't give a damn about the credit windowing. So I know it's a paper exercise, but I think there's some value in separating the documents.
So it is a paper exercise, and it literally all we would do is take the sections. We wouldn't have a technical change. We actually had technical changes to make this all work.
Yeah, no. And
but the next one, whether it's, hey, I get it, yet another RFC, cool. Yeah. So yeah, if we want to do that, I'm happy to do that.
I might suggest Stan's name goes back on the credit one if it goes there, because it is derivative.
I'm easy that way.
Yeah, I think there's actually value in there being two documents because they can be referred to separately.
I don't have a strong opinion on this. I will defer to chairs of which working group I'm not sure, but I will defer to the chairs. And
on a serious note, that's actually a valid question.
I have that as my last slide. Yeah. How many people care about this? Okay. Of the four of you in the room, how many of you want a single document? How many of you want a split? I will do the split. I'm not sure.
75%.
No, everyone. They all did.
Oh, I missed the last time.
Why are we discussing this? Is because the area directors said that MENA work goes in, MENA DLEP work goes here. So this is part of the working group. This is the plan, is to have this part of the working group charter. So Igor is asking, why am I discussing it, and is it merging? I completely defer to the area directors on this. Frankly, personally, I think this meeting highlighted why about to a 75 to 80 degree that they shouldn't be together. But that's not my call. I'll go wherever they say. LMP with an extra letter. That's what it is. The reality is this should have been, they started around, they've been around, both protocols have been around a long time. DLEP is a little younger. It came from a different route. They could have used LMP. They didn't know about it.
My quick point to the mic was, if you want to help splitting the documents, of the four of us in this room, we'll help. It's fine.
Sure, I'll have some co-authors. In terms of actually using these generic components, we have two ways of using it. One of them is the credit extension. That's already a working group document because we've always been doing credit extensions. Ethernet hasn't gone through a adoption poll, so that's why it's draft burger. Obviously, if we did a split, it would continue to be a working group document. If it's MANA, Stan gets to hit OK. If it's CCAMP, we got to reissue all these anyway. Seeing how excited this group is about this topic, I'll try to run through the really interesting meat quickly. We had a couple of technical changes as part of the split. One of the things we did is originally we were looking at the Ethernet data item as being fixed length rather than variable length. The reason for that is with a fixed length, you don't have to worry about the special case and padding of nibbles. The reason why we've now moved to variable length is because everything else in the protocol is variable length, and it was the only place that had fixed length, and it didn't make sense to do that. We also clarified that the scope of the subdata items are the data item within which they reside, and noted in the registry that that's the way it should be. All right, so the first thing that we want to do is confirm the split. And what we've seen is that the split wasn't far enough, and we'll split again. The next is that we'd like to adopt the Ethernet credit. I think those of us that care about this topic all agree it's a good thing.
I have a question about the Ethernet credit. Yeah, I'm +1 from me. There was a personal draft somebody chucked in, I think from Cisco India, about 5 years ago, about trying to wedge VLANs into DLEP. If they're listening, I think it wasn't quite the right way to go. I know you've got your VLAN IDs in there. My quick question was, did you, while putting that together, look at using VIDs without the TOS marking part? So saying, I just want to split on the VLANs. I don't give a damn about the TOS. This
supports it.
It does it? Cool.
And it talks about exactly how to do that. Yeah, basically VID has to be there because that's where the tag has to be there in order to carry the code points. And if you're carrying the tag, you got to know whether or not what the VID value is. Even if it's 0, you still need it.
Just one quick comment. This is Stan Ratliff. I agree with you that these documents are good, and I agree with you that they should be accepted. I'm just not sure if we can make any movement on that until we figure out, based on your comments of a couple hours ago, we've got to make that bigger decision first.
Right. So, Deborah, I'm not sure how we should proceed here on what do we do for working group? So is MANA DLEP work really in here, or is it really not, or should we continue talking, have the ADs battle it out. I think.
Can I add 2 cents on this? The slight problem as well is because Mane was split between PIM because there were multicast parts and DLEP, and there's a clash today. I want to be in both, and they're both happening now. So
if it stays here, we have to put PIM as a first order conflict.
This still has not been actually decided yet, so we will, it's DEPRA for the Meet Echo people. So yeah, we haven't actually decided formally yet. It looks right now like it will come to CCAMP, so we'll continue, and hopefully in about a month, I'd say this should be resolved.
Okay, that'd be great. In terms of where we are in the technical solution, we think the technical solution is pretty solid. We've been looking at it, some implementations, and Rick and we had some offline conversation about actually how to get the traffic control piece to work inside the Linux kernel. So we think that we can get this an open source implementation out there.
And DEPRA again, and if it comes to CCAMP, the reason it's coming is because we are the experts on LMP. So I would encourage you, even if you don't think you're interested in this, take a look at it and help them technically to improve this and to give input. And you may learn something from it.
Mm-hmm. And we'd really appreciate additional comments. And is there anyone in the room who has not raised their hand during this slot who's willing to take a look at these documents and provide comment? Is there anyone interested? All right, you get the prize. It's a free admission to the social. I'm not joking. Sometimes we bribe people. Thank you.
Yeah. Just backing up Lou's comments. DLEP is actually being quite heavily adopted by industry now, possibly slightly different sectors from most of the CCAMP guys, but particularly in the tactical networks, it's being mandated now by large SDOs. SDO.
And it really is about just managing media channels. So all the concepts are it's all the same stuff. It really is. At least from the stuff that I see. All right, thank you.
Well, for sure, if it's not going to be Mane, CCAMP is the right place, I would say.
That works for me. Just as long as the work is proceeding, we can have people that care about it, and so we'll wait to. I guess in terms of a recap of steps, we'll wait to hear what goes on. I would suggest that we do the split as the first CCAMP 00 versions, just so we don't have to confuse things. And then this will obviously need to be polled. The challenge is you're going to get 5 people who have an opinion on this.
Okay.
Or maybe 10. All right, thank you.
Thank you very much. So we are over time. I would just spend 1 minute on the last on my slot. Just one, I promise. So this draft is about technology-specific augmentation to the finite state machine work that is being done in NetMod. The draft describes a number of use cases that apply to basically optical networks, flexible transponders, where we dynamically are allowed to change format, modulation format, and FEC. If I correctly remember, there were some concerns about the usage of finite state machines. These concerns should be raised against the generic model, the one that is being presented in NetMod. And here we should focus on the technology-specific extensions. So please have a look at the draft. Main main changes with respect to the last version, the previous version, regard the synchronization. Basically, when the field state machine changes on a node, we need to have the node at the other end synchronized, and the impact on the rate of the transponder that is used. So please have a look at the document. Please have a look at the generic finite state machine document that is in NetMod.
So
what?
So given this is also about transponders, does it also mean it's not going to be a kind of working group draft until the ITU decides what to do on the
Actually, I think the right step is define transponder augmenting TTP in the T topology, and then maybe work on state on that. But this I talked to Nicola offline. Actually, we are proposing some along the. I'll talk to Igor as well. So we need to have more base model that model a transponder, and then other stuff first, and then most likely I think next IETF we have that draft, and then Nicola would be a co-authors of that. I kind of told him that we need to kind of slow down this until we define transponder model.
So Gert will be happy to hear that we have two dependencies, not just one.
Yeah. So we'll
have to wait for much longer,
but not in a disaggregated fashion. But from network perspective, we need to know something. So starting from there, I think that will make you happy, right? Okay, we work together.
So, Yang Li, I think actually usually we can treat the transport as a kind of special link of WSUN. So I'm not sure if this transport model could be, incorporated into WSUN Yang models.
Actually, WSUN impairment model, I think that's probably more relevant, because why you care about transponder and modulation because of impairment, right? So I think my proposal is, impairment model has this transponder aspects augmenting TTP, and then characterize some of the behaviors there. Is that acceptable?
Makes sense.
Yeah.
Makes sense.
Okay.
Okay. Thank you, everyone. The session is concluded. Apologize again for the delay. Every time we ask for more time is never enough. We'll try to fix this.
Where are the blue sheets? Yeah.
Why are you so I'm going to talk.
Louis not coming. Louis not coming. He just give away the ticket.